Pre-statistics, Residual Analysis, Part 3. Lesson objective: graph the residual plot for a regression equation to help determine the best model. We'll begin with example number 4. Consider the data involving the U.S. population before the Civil War. Let T be the number of years since 1790. Which regression model, linear, quadratic, or exponential, is the most appropriate for this data set? Once you have the data inputted into list 1 and list 2, we want to create a scatter plot to see the pattern of the data. Second, y equals the stat plot. Hit enter. We need to change the y list to list 2 instead of residual. There's a number of different ways to do that. One way is hit second stat for list. We want number 2 for list 2. Next, we want to hit zoom and number 9. Here's our scatter plot. This appears to have a curve pattern to it. Let's begin with the linear regression command. I'll go to stat, go to calculate, number 4. We hit calculate, and our slope is about 0.375, and the y-intercept is 0.723, rounded off to 3 decimal places. Our square is about 0.9199, so our square is pretty large. Let's graph this equation with the data set. So I'll go to vars, number 5 for statistics, number 1 for regression equation, then we hit graph. The linear regression is doing a pretty good job. Here we see this residual is positive, this is negative, this one's negative, 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 this one's close to 0, and this one's positive. So there does seem to be a pattern here, and let's see if the residual plot will show us that pattern. So we go back to stat plot. We need to change the y list to the residuals. Second stat is list, number 7 is residual, and then we need to finally hit zoom stat. Let me go back and turn off the line of best fit. Clearly this is a quadratic pattern. So here we saw those positive residuals, then those negative residuals, then back to a positive. So this is telling us there is likely a better model. So let's start with the quadratic. So if I go to stat, calculate, number 5, this time I'm going to go ahead and store the equation from this window. So I hit vars, y vars. I don't want it in list 1. My linear is in list 1. Let's go with list 2. And then we hit calculate. My r square is 0.996. Because both the linear and the quadratic are polynomials, the r square value for a quadratic is always equal to or greater than the linear. Let's look at the regression equation along with the scatter plot. So now I want to change this back to L2. Then I need to hit zoom again and number 9. Yeah, this is fitting this point a lot better, this curve is being modeled very well by the quadratic curve. Let's look at the residual plot for the quadratic. I go back to stat plot. I want number 1, and instead of doing list 2 for the y, we want back to residual. Now this residual list is for the quadratic. That's the last regression command I did, so this automatically updates each time I do a regression. And then I need to hit zoom and number 9. And if we look carefully, we can even see there is a pattern with the quadratic. Then this is clearly this is better than the linear, but maybe the exponential will be even better. So let's try it. We go to stat, calculate, and 0 is the exponential regression. Okay, list 1, list 2 looks good. I'm now going to store this in L3. So I hit vars, y vars, function number 3 for y3, and then we hit calculate. We see that the value of a, the initial value, was 3.957. The base is 1.03. So that means that this is an increasing function, and of course we saw that from the pattern in the data, and we see that the growth rate is about 3%. R squared is 0.9999 rounded off, so that is very, very, very close to 1. Okay, let's go to our y equals, and let's turn the quadratic off, and let's look at the exponential with the data. So one last step, I need to go to stat plot and change it back to L2. And then finally we want zoom number 9, zoom stat. I believe, according to the scatter plot, this is even better than the quadratic, but the quadratic was also good. Let's look at the residual plot for the exponential. So I'll change this back. Number 7 is residual, and we want zoom number 9. Out of the 3 residual plots, this one is definitely the most random. There almost looks like there's a pattern going on here too, but it's not as pronounced as the linear or the quadratic. So according to the scatter plot, it looks like the exponential did the best job. The exponential had the highest R square value, and with the residual plot, I think the exponential is the best out of the 3. So let's summarize example 4. The linear regression model was L of t equals 0.375t plus 0.723, had an R square value of 0.920. For the quadratic, Q of t equaled 0.005 t squared minus 0.003 t plus 4.501. It had an R square value of 0.996. For the exponential, E of t was equal to 3.957 times 1.03 raised to the t power, and it had the largest R square value of 0.9999. So the scatter plot for the linear function along with the residual plot showed a pattern in the residuals. The quadratic also showed a pattern in the residuals, and the exponential was the residual plot that had the most random pattern. So based upon the scatter plot, R square, and the residual plots, the exponential function is the most appropriate for this data set. Now you may question, since R square was the largest value, why do we need to look at the residual plots and the scatter plots? Why can't we just look at which function has the largest R square value and say that should be the best model? We will look at that in the next video. Thanks for watching.